Hello there. This time, we'll learn how to solve for the asymptotes of a rational function. An asymptote is a line or a curve that the graph of a function gets close to but does not touch. In our vernacular expression, we say the asymptote is you get closer and closer to each other, but you're never meant to be together. It means that you get closer and closer to the line or to the curve, but it will never touch or cross the line. The line x equals a is called the vertical asymptote, while the line y equals b is the horizontal asymptote. Based on the drawing, the horizontal asymptote lies this one. So the horizontal asymptote is y equals 3. The vertical asymptote is a vertical line where this graph will never cross. So our vertical asymptote for this figure is x equals -2. So if you see, the graph never crosses by x equals -2 and y equals 3. Now, how to solve for the vertical asymptotes? Now, there are restrictions. Let's start with the vertical asymptotes. There are restrictions that will make your rational function undefined. Remember your domain? Remember the previous one? X is not equal to 2. So if x is not equal to 2, our vertical asymptote is x is equal to 2. You just change the not equal sign to equal. If your domain is x is not equal to -3 and 3, then we have two vertical asymptotes. We have x equals -3 and x equals 3. Let's take this example. After simplifying, our denominators should have restrictions at -2 and 3. This is our domain. X should not be equal to -2 and 3. But upon simplifying, we have canceled x plus 2. So what will happen? The uncancelled one, which is x is not equal to 3, will become the vertical asymptote. X is equal to 3. The cancelled value, x plus 2, which makes the domain x is not equal to -2, becomes our whole. That will be x is equal to -2. A whole is a circle which is not shaded. We'll talk more about this in the next lesson on graphing rational functions. Now, the next one, how to solve for horizontal asymptotes. You only need to find the degree of the numerator and the denominator. To be sure with that one, you need to arrange the exponents from the highest to the lowest. For example, in number 1, the degree of the numerator is 0, since there's no variable. The exponent of the denominator is 1. For the second one, the exponent of the numerator is 1, while the second, it's still 1. For the third example, the exponent is 2, while for the denominator, the exponent is 1. Now, how to identify our horizontal asymptotes? If the degree of the numerator is less than of that of the denominator, the horizontal asymptote is automatically y equals 0. If they have the same degrees for the numerator and denominator, then we need to copy their leading coefficient. It means their numerical coefficient, a divided by b. If the numerator's degree is greater than the denominator's degree, then there is no horizontal asymptote. For example, in the first one, the numerator's degree is less than of the denominator. So our horizontal asymptote is y equals 0. For the second example, both are equal. So we divide their leading coefficients. That's 5 over 2. So our horizontal asymptote is y equals 5 over 2. For the third example, the numerator's degree is greater than that of the denominator. So there is no horizontal asymptote. If there's no horizontal asymptote, then we expect an oblique or slant asymptote. How do we do it? We divide the numerator by the denominator using long division or synthetic division. The quotient, and you need to ignore the remainder, will be the equation for the oblique asymptote. Let's try to answer these examples. For example, here you could refer going back to your domain. Our vertical asymptote is -1. Just refer to the denominator or to the domain of the function. Since the denominator's degree is higher than the numerator, then our horizontal asymptote is y equals 0. For the second example, consider the denominator for the vertical asymptote equals 0. So x is equal to 4. For the horizontal asymptote, the degree of the numerator is 1. And the degree of the denominator is also 1. So we divide the leading coefficients. That's y equals 5 over 2. For example C, let's take the vertical asymptote from the denominator. X squared minus 4 is equal to 0. We do transposition. X squared is equal to 4. You find the square roots of both sides. So the square root of x squared is x. The square root of 4 is 2 and -2. For the horizontal asymptote, the degree of the denominator is greater. So our horizontal asymptote is y equals 0. Let's have example D. For the vertical asymptote, we equate our denominator by 0. But if we simplify this expression, the 2x minus 2, will be cancelled. So x equals 2 is considered as the whole. What's left? X plus 3 is equal to 0. So x is equal to -3. For our horizontal asymptote, the degree of the numerator is 2. The degree of the denominator is also 2. They are the same. So we need to divide our leading coefficients. That's 1 divided by 1. So the answer is y equals 1. That's the horizontal asymptote. Let's consider example E. For the vertical asymptote, we equate our denominator by 0. So x minus 2 equals 0. Do transposition to the other side, it will become x equals 2. For the horizontal asymptote, the numerator's degree is 2. The denominator's degree is 1. Since the numerator's degree is greater than the denominator, then there is no horizontal asymptote. Instead, we have an oblique asymptote. So we divide the numerator by the denominator. It will give you the answer 2x minus 1 minus 5 over x minus 2. 5 over x minus 2 is the remainder part, so ignore it. So the equation of our oblique asymptote is y equals 2x minus 1. This ends our topic on asymptotes.